next speaker is Alejandro González from the Department of Microbiology.
Buenos días a todos, soy Alejandro González, doctorando del primer año, en realidad del primer mes prácticamente. Estoy dirigido por los doctores Francisco Martínez Abarca y Nicolás Toro García del Departamento de Microbiología y Sistemas Simbióticos, y ya que se da la oportunidad voy a intentar hacer esta presentación en inglés. Bueno, intentar no hacerlo. The topic of this exposition is reverse transcriptase RTs associated with cluster regularly interspatial short palindromic repeats, known as CRISPR elements. Reverse transcriptase RT are enzymes capable of catalyzing the DNA polymerization from an RNA substrate. An example is the IHIV-RT, which has 7 different domains. The most abundant RT are encoded by genes contained in mobile genetic elements, known as retroelements, able to move from one place to another place in a genome and spread through a RNA intermediary. The retroelements are both in prokaryotes and eukaryotes. Examples of bacterial RTs are group 2 introns and the newly discovered RT associated with CRISPR elements. Phylogenetic studies of our group based on data of RTs from bacterial genomes reveal that the bacteria's RT can be classified into 17 major groups. Among these groups, there are a majority groups, group 2 introns. Curiously, in the base of this branch, there are a new group of RTs annotated as CRISPR associated. The CRISPR element are being a revolution in medicine and in other fields. But the function of the RTs are still understood. But what are CRISPR systems? CRISPR system, cluster regular interspace short palindromic repeats, are an immunity system that have been developed in prokaryotes to protect against the invasive DNA of phages and plasmids. The CRISPR systems are organized into loci formed by a CRISPR array, which has small DNAs known as direct repeats, and separated by non-repeat sequences known as spacer, which correspond with the invasive DNA. Secondly is the leader sequence, which is upstream of the CRISPR array, where is the promoter necessary to the transcription of this array. And finally, a variable number of Cas genes, which provide the enzymatic machinery necessary for the acquisition of new spacer into the array of the cleavage of the invasive DNA. The immunity mediated by CRISPR systems have 3 steps: adaptation, expression, and interference. We will focus on the first step, adaptation. In this step, exogenous DNA sequence from plasmids, phage, known as protospacer are incorporating as a new spacer into the CRISPR array. In this stage, the enzymes who participate are Cas1 and Cas2, and the nucleases present in the most CRISPR-Cas systems. But what is the role of the RTs in this context? Recently, studies in a paper of the 2016 inferred that RTCas1 fusion protein is capable of incorporating new spacer from RNA to the arrays in an active RT-dependent way. But this function isn't clear. What is the real function of the RTs in CRISPR-Cas systems? This is the objective of our work: characterize different groups of RTs associated with CRISPR elements in prokaryotes. The starting point of my thesis consists in an in silico analysis of the genomic context of these RTs. For this purpose, we analyze 20 kilobases of the genomic context upstream and downstream of the opening reading frame of the RTs, looking for the proteins Cas1 and Cas2. Thus, we can see that in all of the cases we analyze, we can see the genes encode Cas1 and Cas2 proteins. Moreover, we use different online tools to define the CRISPR arrays present in these contents. CRISPR arrays in the different contexts analyzed. After analyzing this context, the expression and purification of the RTs were carried out to define the properties in vitro of these RTs. We use an in vitro assay, and the result of this assay was that two of the RTs studied show a significant activity. 432N2 from the cyanobacteria Stridolema hoffmanni and 439 from the Protobacteria Vibrio vulnificus. Also, these RTs present two different distincts because 432N2 is independent of Cas1, whereas 439 is a RT-Cas1 fusion protein, like the protein of Mariomonas mediterranea. To discover the real role of these RTs in our CRISPR systems, we will use in vivo assays cloning the adaptive operon into heterologous host or in the same bacteria which it was isolated for our final aim, to demonstrate that the presence of CRISPR systems are dependent to open novel functions distinct to this adaptive immunity system. That's all. Thank you so much.
Thank you very much, Alejandro, for explaining us this very exciting and new topic. But I meet people who have nothing to do with the academic world, and they want to know what is CRISPR. You know, people say it's a kind of molecular scissor, but try to explain very shortly for somebody who has nothing to do with research what is CRISPR.
Bueno, si me permites te contesto en español, que va a ser más fácil para que lo podáis entender. Así, en un grosso modo lo que he dicho, la función biológica a priori que se conoce, aunque puede que no sea, y de hecho ya se han dado nuevas funciones, es un sistema inmunitario que está presente en bacterias y arqueas, pero que ahora mismo en biotecnología o en medicina se está usando como un sistema como una especie de mutagénesis dirigida, porque estos sistemas son capaces, dentro de las tres etapas que hay, en la etapa de interferencia, son capaces de dirigirse a cualquier parte del genoma, más o menos, que nosotros queramos. Entonces pueden cortar la expresión de un gen, hacer que se promueva la expresión de ese gen, y esto se está empezando a hacer ensayos. De hecho, por ejemplo, en China hace poco se han hecho pruebas en ratones contra el cáncer de pulmón y han visto cómo son capaces de reducir el tumor, y la verdad que tiene un montón de aplicaciones y que es un sistema que a partir de ahora se empezará a oír cada vez más.
Muy bien. Y recordar que CRISPR fue un
descubrimiento español
y que luego lo desarrollaron dos investigadoras que le dieron el Príncipe de Asturias, pero que todavía ninguno de los tres, ni al español ni a ella, le han dado el premio Nobel. Pero
sí, estuvo este año, que ojalá se lo den en algún año venidero, porque la verdad que el sistema tiene un futuro bastante importante.
Gracias.